So this is ASFurther Maths. We're in Unit 2 and we're finding the inverse of a 3 by 3 matrix. There's a few wee steps here. So what we do first of all is of course find our determinant. Then we find our matrix of minors, then our matrix of cofactors, and then we transpose it to get our final answer. If you click on this wee link, it'll be a very old video of me going through it, so I'm not going to do this example. I'm actually going to do the next example here, but it's very much the same plan. You could sit and do that for a bit of practice yourself. But we're actually going to take a look then at example 5, which is this one here. So first of all, we're going to work out a determinant. So it's going to be 1 upon AD minus BC, so minus 20 minus 2, so it's going to be minus 22. And of course remember it's minus 2, the bit people forget. 12 take away 2, which is 10, plus 7, 3 minus 5, which is 8. So we have minus 22 minus 20 plus 56. And so our determinant then is going to be 14. First of all, then we're going to find our matrix of minors, and we go through all 9 elements and we do the cover-up method. So I'm going to get 2 pencils here. Hopefully you'll be able to vaguely see it whenever I do it. So for the first one, we cover up that row. Can you see the rest? You can, and cover up that column, and we find the determinant effectively of the minus 5, 2, 1 and 4. Now I've done this one before because we've already done our top row. So minus 5 times 4 gives me minus 20, take away 2, so it's minus 22. So we exchange our 1 here for a minus 22. The 2, cover up this row, cover up this column, 12 take away 2, which is 10. And then for the 7, cover up this row, cover this column, 3 minus 5, which is 8. For the 3, let's cover this one up and see what we have. Hopefully you can see it on the video, just about. We're left with 2, 7, 1, 4. So 2 times 4 gives me 8. Take away 7, so we're going to end up then with a 1. Middle row, middle column, can you see that? So we have 1, 7, 1 and 4. So we have 4 take away 7, so it's minus 3. Row, column, if you can cover it up and leave a wee bit of space, that's not too bad. 1 times 1 gives me 1, take away 2, so I think then we have minus 1. Bottom row, column, then so we have 4 minus 35, so that gives us 39. Here we have 1 times 2 is 2, take away 21, minus 19. And then finally, minus 5 minus 6, so that then is going to be minus 11. So that's our matrix of minors. For part 2, let's write minors up there, so it's spell. And cofactors. We pretty much apply this wee grid to it. So it's going to be plus, minus, plus, minus, plus, minus, plus, minus, plus. And we change the signs of these 4 elements here. So that's going to give us minus 22, minus 10, 8, minus 1, minus 3, 1, 39, 19, minus 11. So what have I done? I've changed the sign of this one, this one, this one, and this one. So that's our second bit. And then finally we want to transpose it, so where the first row will become the first column, and so on. Can't spell transpose, but you get the idea. So it's going to be the minus 22, minus 10, 8, minus 1, minus 3, 1, 39, 19, minus 11. So therefore our inverse matrix m to the minus 1 is 1 over 14 upon minus 22 minus 1, 39 minus 10 minus 3, 19, 8, 1 minus 11. We could of course check by multiplying through by m to make sure that we get 1, 0, 0, 0, 1, 0, 0, 0, 1, which would of course work. That's always a good check then to see that we've found the correct inverse.